Alright, for now I'm just gonna do this here. So as I was saying, we're gonna be approaching -1 on this equation right here. Um, so we're approaching -1, but the thing is, on the other equation, it's at 1, so it's not continuous. So from um, from negative infinity to -1. And -1 to infinity. I'm gonna go after, we'll go over the quiz problems after. Um, and then this one, you could just factor it, and then x plus 3. Okay. From here, the bottom would equal 0 when x is -3, because -3 plus 3 right here, and you would get 0 times x plus 3 right here, But yeah, so that's where you would have a discontinuity. So it would be negative infinity to -3, and then from -3 to infinity. Um, x to the power of 3. So this is just negative infinity to infinity. Any polynomial like this one right here is just continuous. Okay, so these trig ones are a bit tricky, but basically, when is there a discontinuity? So there's either, if you remember, the essential, which is an asymptote. So when it's like that and like that, or when there's a jump like that, and it jumps from here, or a removable one. I'll just put that where it looks like that. Okay, but this right here, we could just turn this into this. This is the same thing. This is the same thing. It's just flipped. So this is the same thing if you were to do equals. 1 over sine 1 over sine of 2x is the same thing as cosecant 2x. So, but we're only looking at this interval right here of negative pi to pi. We're only looking at that interval. So when does the bottom equal 0? So if we remember the unit circle, sine is y. So y is 0 right here and right here. So if we put in negative pi, because that's the interval that we're using, you're going to get 2 pi sine of 2 pi on the bottom over 1. And sine of 2 pi is right here, and that's 0. So then there would be 1 at negative pi. Then pi over half is right here, but it's 2 times pi over half, so then it would come right here. So it would be 2 pi over half, so then that would be, 2 pi over 2, and that just turns into pi, which is right here, and that's 0. That's another one. So it would be negative pi over 2. 0 radians or degrees is also right here, and that's where the bottom would also equal 0. Then it's the same thing. It would be pi over 2 because, oh, by the way, negative, that means you would be going this way, but it's the same thing. You go negative pi, and you end up right there. You go negative pi and a half, and you end up, sorry, negative pi times 2, you would end up like all the way around right there. And then negative pi over 2, you would just end up right there. So then, I could just have that. And it would be an essential, or removable. No. Yeah, it would be essential. Yeah, essential. at these points. It's a lot, but that one's, I'm gonna be honest, continuity with trig, you're not really gonna see that on the AP exam, so don't even worry about it too much. So this one, we see that we have x squared minus 10x plus 24. So we're gonna make this a limit as x approaches 3, which is x squared minus 10x plus 24, which is equal to, so 9 minus, and then 3 is 30 plus 24. So these turn into negative 6, and then 9, which is equal to 3. So on the graph, when whatever x squared minus 10x plus 24 looks like, when it reaches 3, it's about to get to the y level of 3. There's a hole right there. Right, there's a little hole. But the other function, y equals 4, means that there's a thing right there. So it would be a removable discontinuity because you could take that point out. So it would be removable discontinuity at x equals 3. We can factor this, so it would be negative x minus 3 over x minus 3 times x plus 1. Cancel those out. Negative 1 over x plus 1. And then this right here is a whole, which is the same thing as removable discontinuity, if I'm not wrong. Yeah. So there's a removable discontinuity at x equals 3. P is equal to x minus 3 is equal to 0, plus 3 on both sides, 3. So x equals 3. And then this bottom equation would be 0 when x is negative 1. Because negative 1 plus 1 equals 0, and you can't have that. So then that would mean x plus 1, I don't know what it would look like, but just imagine this. And it has an asymptote right at 0, so then it would be essential. Essential is just when you have an asymptote at x equals 0. I mean 1, sorry, at 1. Because when you plug in negative 1, it would be a negative 1. I'm so sorry. Right here, all we have is this, and it would be 0 when you have negative 1 again. So another essential. Discontinuity at x equals negative 1. Right here, we just get the limit as x approaches. So we see that if we could even like plug in all numbers here, and you can, because you can plug in every number on this function except for 2, but then this function you gotta plug into. So, and then x squared minus 2x, 4 minus 2 is equal to 2. So that would mean, oh yeah, hold up, I'm sorry, I did that wrong. 2 minus 2 times 2 is 4, so then that would be 0. So then they don't match. This is at 0, and you get 2 over here. So that means the x squared minus 2 graph reached to like, I went like this, and then I had a hole right there, and then a dot at 2. So then we would have a removable discontinuity at x equals 2. And then right here you would, this would be maybe a jump, but we would see if they like plug in. So then for the top you would put the limit as x approaches -1 from the left, negative x over 2 plus a half. Plug in -1 would be half plus half, which is equal to 1, but that doesn't match with 2, so then that is a jump discontinuity. So basically, what that looks like I said, just imagine, so after -1, so after -1 is just a straight line at 2, it would have the dot, and I don't know what the other graph would look like, but it would probably look something like this. Oh, okay, wait, hold up. It looks something like this. And then because this is at 1, because we got 1 right here, the y-axis, approaching -1 from the left, it would reach -1. However, the other equation, y equals 2, from the right, it reaches another spot, which is 2, right? So then you would have a jump discontinuity at x equals -1. Right here, we could factor, from what I could see, x minus 1 over x plus 3. So that's a whole, so then that means removable. Remember, removable means that you can remove the dot, which is where that hole is. At x is equal to -3, because that only happens when -3 plus 3, which gives you 0. So then you just have x minus 1, so you can't really do anything more with that, so you just have, for 15, a removable discontinuity. So right here, you can factor again, which would be like this, x minus 1, like that, negative x minus 1. Right, you can't do nothing. This is a whole again, so it would be a removable discontinuity at x is equal to -3. And then for this one, you would just do the limit as x approaches 2 of x squared plus 4x plus 3. Just plug in 2, 4 plus 4. Sorry, it's a -2. We're supposed to be plugging in a -2. So then you would get 4 minus 8 plus 3. It's the same thing as -4 plus 3, which is equal to -1, but it's not the same thing as 0. So then that would be a removable discontinuity at x is equal to -2. So these are a bit tricky. So basically, you have something like this. This isn't what the function would look like, but this is just an example. Cosine looks something like that. But when you, let's say you were to plug in pi down here, that would be pi minus pi, which would give you 0, and you can't have that. And we're looking for discontinuities. So when you plug in pi, I'm not sure what that would look like, but you would at one point get something that looks like this. So it's like hitting a bunch of points at the same time, which is really when you're probably like, okay, but what does that mean? That means that it's not really it's approaching everywhere at the same time. It's approaching up, down, up, down, up, down, up, down, up, down as you approach pi. That's not what it would look like, but it's just an example. So then this would be an um, an oscillating discontinuity at x equals pi. And then this one, just get the limit as x approaches -2, x squared plus 4x plus 2. Plug it in, you get 4 minus 8 plus 2. Same thing as -4 plus 2, which is -2. This and this are not the same. So then you have a removable disk at x minus 2. And next one, this is the same thing. So its cosine is going like this. As it approaches 0, just, I don't know why, it just starts going like that, and then it like continues the same. So like, for example, at 0, since we can't have 0, but the thing is, if you plug this in into a calculator, and you graph it, it's gonna be like this, which is really weird. So as we get to 0, it's not approaching anything. It's going up and down. You get me? It's like if we had a regular graph, it's just a graph, and all of a sudden, when it started coming to a point, it just went, and then just kept going. You would be like, okay, as x approaches that spot, it's landing at what y value? We don't know. I mean, it's trying to like go everywhere. So then this would be an oscillation. That's what this is called for some reason. Oscillation, discontinuity at x equals 0. And for this other one, we just do the limit as x approaches 0 from the left of negative x squared minus 4x. Oh, we would have to do it on both bottom and top. Plug in 0, you get -5, and you do the other one limit as x approaches 0 from the right of sorry, I blanked out. X over 2 minus 3 over 2. Plug in 0, just get -3 over 2. This is basically what this shows is that negative x squared is going to look something like this. And as it's going up, it's just going to reach -5. And then the other one is at -3 over 2, which is like probably right here. And it's going to go like that. And that's a jump discontinuity. At x equals, and as we approach 0. This one, we can factor out. So then we can factor this out to x minus 1 and x minus 1. These cancel out, so that means that there's a hole, which is the same thing as removable, which is just this type of graph. You know, basically what it means. At 1, okay, 1 minus 1, that gives you 0. It would be a different number, so then it would be a removable discontinuity at x equals 1. Right? Let me see if I'm right. Yeah. Alright, just 3 more problems. So this one's an interesting one. I had to graph this, and it looks something like this, which is really weird. So it goes like this, and then as it gets closer, it gets like smaller, and it starts getting like a bunch of times, and then it starts going like just going like that, which is really weird. But remember, when we find the limit of sine over 1x of 0, it can't equal 0 because it's like going everywhere at the same time. But since we have another function, so imagine we had a hole right here at 0. I don't know where it would be at, right? We would just have a hole there. However, y equals 0, would be a flat line at y equals 0. You just wouldn't see it. and that means a spot at x equals 0 is taken. So we can't plug in 0 to the top, right? But that means that at 0, it's 0. So then that means it's continuous. Basically, what I just said is imagine if we had, I don't know, imagine this was just x, but it can't equal 0, right? And we had the other function of 0, which is just y equals 0, is y equals x. So then that would just be a line going like that. But the thing is, x cannot equal 0. So the function x cannot equal 0, and the function y equals 0 can only be at x equals 0. So that means it's going to plant a dot inside right here. That's like the best way I can explain it. So then this one you would just do the limit as x approaches -2 from the left of -x over 2 minus 5 over 2. Plug in -2, get 1, you get 2 minus, so then you get -3, 2. And for the other equation, you get x right there. Sorry, I'm blanking out. Then you get -2 as it approaches from the right of -x squared minus 2x, which is equal to, so you plug in -2, you get -4 plus 4, which is equal to 0. You don't get the same thing, so then that would be a jump. Discontinuity. Discontinuity at x equals -2. And for the last two, just factor them out. Never mind, you cannot factor them out. Yeah, you can't. So then we will try to find out when this bottom number equals 0. Let's see if there's like anything. Thing is that, you know, if you try to make this equal to 0, you're gonna get 2x squared plus 2x equals 1. And then I guess factor out x, 2x plus 2 equals 1. And then basically, I'm not going to show you the whole thing, but this, it doesn't touch, it's not going to touch 0 at all. Alright, it's not going to touch, so if the bottom can never equal 0, then there's going to be no discontinuity, so it's just going to be continuous overall. And this last one is the same thing as saying -x over x plus 2 over x plus 2. That makes a whole, which means it's removable. For last time, it would be like that. It would be something like that. Right? It's removable. You can move it, which is why it's called a whole. At -2. So, yeah, that's everything.